Okay, Chuck, so I know a little bit your answer to these questions, but I think it's interesting to ask you the same question, which is why a computer? And I think that's just to say that at the time, it was not an obvious thing. You had to go seek them out and find them, and you had to anticipate something in it. What were you looking for in your work, and did you even need a computer to do your work?
Well, I'd say that the computer probably raised at the time fewer philosophical conundrums than we heard with Peter. I come at it, I was introduced to computers in engineering school, and the use of the computer was in a context really of exposure to technology and the engineering disciplines. So, for example, I studied mechanical engineering, but I could have simply chosen another discipline, computer science. And in that context, it really was kind of a topic in its own right, and at the same time, it was a way that you could facilitate studying about engineering. For me, I mean, I think the fact that computers were really coming to the fore as I was conceiving of my project of working with expandable and transformable structures was, it was fortuitous to say the least, because it was a constant, it was really always there as an enabler of what I liked to think about. Mm-hmm. There never was a kind of a disjuncture where I said, oh my God, this is like changing the nature of what I do, or whether by sort of contradiction or by support. It was always there as a way that really just kept this project going and allowed me to keep making explorations I couldn't have done otherwise.
Mm-hmm. And I mean, this is maybe jumping way ahead, but in the exhibition there are a lot of origami surfaces and what otherwise I would call topologies, surfaces that are capable of transforming from one shape to another continuously. How much of that shift from Cartesian coordinates in space that moved to surfaces or topologies that moved, how much of that were you already working on before the computer and how much after?
I never actually touched origami. I mean, as a kid, of course, I made folding cranes and such, but that's more like you followed a set of instructions and you could maybe take the crane and animate it, but the idea of origami was more making a shape from a piece of paper. When I actually got involved with origami as a designer, I was interested in the idea of the kinetic origami, so the notion of self-folding, like, origami fundamentally is a sheet that turns into a shape. Mm-hmm. And could I make sheets that turn into a shape that would do it in some sort of a continuous, a little push and a pull, and, and forms would appear. But those explorations of origami were really through the lens of mechanisms, because I was a mechanisms, that's what I studied in engineering school, was mechanisms design. So I was working with that frame for thinking about origami, and as a mechanisms designer, there was a lot of mathematics and computation that was supporting the making of those. But I think if I understand your question, vis-a-vis the origami shapes as compared to the more mechanical pieces, they're mechanical meaning discrete elements made by connections. They're in a continuum of mechanism behavior. Mm-hmm. A lot of what I thought about then and I think about now is behavior, is action, is animate form, to mm-hmm. use a phrase.
Mm-hmm. And in the way you were working, if you could just describe how you worked then versus how you work now, if it's changed at all. I mean, I know that there was initial drafting of joints and connections to verify the transformation. And at a certain point, there was then coding of that and writing your own scripts. And
there's, in terms of the way that I work, there's been changes, but I would say that they're kind of, it's surprisingly, maybe unfortunately, similar to how I did it 25 years ago. I mean, you kind of learn a way of working, and I think all of us are that way. It tends to be, you know, it's hard to stop doing what you're doing and then do it in a new way. In terms of the process by which I conceive of the objects in the show and the way I conceive of objects now, I mean, the first, the starting point is entirely cerebral in that sense. You know, it is, I kind of get, I get that idea of, that Peter's alluding to. You have to have an idea. And in my case, the idea is, it's about mathematics, it's about geometry, it's something that if I can't visualize it purely mentally, I can't design with a computer, I can't even sketching it. Sketching is a little bit more that feedback of, there's something about the way the hand in your mind works that you may actually get that type of insight. But once it went to the computation, it had already been kind of encoded in probably some formula and then into the computer script. The thing that the computer did for me then and continues to do for me now is basically there's certain inherent complexities with mechanisms design, and the ability to visualize was always like a kind of it's really the ability to visualize a particular unit or piece of a larger structure. And my insight is always how that piece may be aggregated into an overall structure. So there's a behavior of the unit, but that will aggregate into kind of a systems behavior at a larger scale. But what I can't do is kind of visualize the permutations and complexities as you look at all the variations of that. Mm-hmm. And the computer, allowed for that then and continues to do so.
And I know in the interview with Bill Record, he was very struck by your ability to take elements that had material thickness, otherwise called solid models, solid objects, and figure out how those would rotate and move through each other with complex hinge points and rotations and things. I also know that a lot of this software at the time, you couldn't really visualize things very well. So how
yeah,
were you
but it
working
was,
that out?
but even at the time, you couldn't. Well, you couldn't visualize it well compared to what we can do now, but you could visualize it a whole lot better than you could drafting it. There's a few aspects there. If you may note in the show, there's some graphics of origami shapes that I had visualized on the computer, but I also coded them on the computer and also coded how the computer would graphically represent them on the screen. So the material thickness, basically this was kind of not pre-CAD, but pre-CAD for the working man or working woman. It was really, CAD was only accessible to aerospace companies or military or maybe a bit with Hollywood. So with material thickness, I was writing the program that would basically say, this is the thickness of material that I want, so it visualized exactly what I wanted it to do. The nice thing, programming is, it's something I don't do a great deal of now, and it's virtually ubiquitous now in architecture schools, scripting and programming. But at the time, I think it had a kind of a different quality because, when I studied engineering, we started with machine language, with assembly language, with ones and zeros. There was even a course in punch cards that I took. There's a kind of a craft, there was a craft feeling that it had. Mm-hmm. There was something making about it. Mm-hmm. It wasn't, it was a kind of a form in making. Mm-hmm. It was not just a tool that you could access. And I think it's actually much better now that you don't have to go through all that, and yet something gets lost as well.
Mm-hmm. I know there's a misconception that drawing and modeling was far in advance of manufacturing, and that people thought we needed to find new materials or new machines or be able to 3D print entire buildings or something like that. From your background, you already had knowledge of computer-controlled manufacturing processes. Was that something you were always designing for?
When I graduated from Columbia in about 1985, I worked for 5 years for a startup robotics company called Honeybee Robotics, and we did a lot of really fun projects, both for industry and for government, for the space agency. But that was where I really learned about manufacturing, and Bill Record was our machinist at the time and a very talented engineer besides. So computer control, it was like my learning about computer-controlled machining processes was sort of it was like being at the hands of sort of in the hands of a master. Bill, who had a machine shop and kind of a beard down to here and had a company which was very aptly named Zengineering. And, he really taught me, like, how you can go from these, you can go from really, at that point, a sketch. A lot of time, it was kind of an interesting process thinking back. You would sketch something, and then at that point, sometimes Bill would just take it over and go, like, this is how we can code it up for the machine. So it wasn't always it always wasn't this very kind of analytic process. It was just being in touch with the tools that were available. CNC machining, which is a process of subtraction, of taking solid metal and removing parts, that actually is, that's been in part of industrial production for, many decades before computers became kind of accessible to, on a consumer level. So, that was really part of, again, that engineering stream.
Mm-hmm. And in terms of scale, obviously this works to a certain scale, at which point other things become more logical.
In terms of going up in scale or down in scale?
Well, you could probably go up almost infinitely, but down you go then into 3D printing and things like that, and laser cutting and...
Yeah, and all of the 3D printing and laser cutting, it's hard to remember exactly the timing, but there was that process in, through the sort of early 90s where these types of machines started to come online, but it was like it was this very kind of it was a process where you would sometimes FedEx an envelope with a disk in it, and a service bureau would make something for you. 3D printing was always just this, incredibly cool. The notion that you could send a FedEx envelope and get an object back at the time already was like, that pretty much felt like the future. Mm-hmm. When we were doing a lot of our prototypes, 3D printing was, it actually still is fairly expensive, but it was very expensive then. So sometimes to reproduce pieces, we would get a single 3D print back and then make a silicon mold and just reproduce it over and over with, with some kind of a urethane casting process.
And is that the royal we, or is that you in your studio?
Me in my studio. But, I would say that it probably was reproduced in other design studios, mm-hmm. other design studios as well. There's always been a strong culture of making, in terms of being interested in mechanisms and behavior. If you don't, there's a, kind of a, you can get this far with visualization and computation and even insight, and then you have to build it and see what it does, and and if that be animism, so be it. It's
And so, in terms of collaborations and what the rest of the field was doing and things like that, could you talk a little bit about, I know this morning you said that the expanding sphere and the iris dome were really thought of together, and you were thinking of those abstractly, I'm sure, as a kind of mechanical system, but you were also thinking about a lot of different scales.
Well, it's actually kind of it's a very trying to think of the word. It's a profound experience actually to be in this show and to be, I'm not an architect, but to be in an architecture show of this type among other architects, my dad's an architect, and I had, in a sense, kind of sidestepped architecture. I went to art school originally. I then went to engineering school, so I was kind of straddling and making sure I didn't step right in the middle. Mm-hmm. And at the same time, there's like there's this kind of gravitational pull, and I think that that's the sense that making these, thinking about transformable objects, you are kind of inexorably led, well, then what about transformable spaces? And what is this for architecture? And I think that there's something about that it has a gravitational pull, it has a fascination. It's hard, it's kind of, you can explain it in many different ways, and none of them are entirely convincing. When I made the two models in the exhibit, the iris dome and the expanding dome, it was a kind of a setting forward my sort of like two threads of what I thought were interesting directions for transformable architecture. One, the notion of expansion, deployability, portability, everything that represents, and the other about retractability, about fixed structures. And one is, kind of the idea of growth, and the other is sort of the idea of disappearance in some way. If something retracts, it retracts to something, and it, maybe is no longer visible as a thing, it becomes just space itself. I still think that those are two very, they're good axes for thinking about this, this thing that is still a possibility, I would say.
Mm-hmm. In terms of building work, which is not in the show, I mean, I know you've done a lot of work with kind of variable shading structures for facades and things that change aperture. I mean, seems like the holy grail, because it's a dome, is a stadium. I mean, we heard that yesterday. Everybody kept saying at dinner that you need to fix Montreal Stadium. Well, do the new Montreal Stadium. So, but I'm just curious how much traction this also has in other kinds of problems than just long span.
The making of the Iris Dome as a as a proposal for a retractable roof over a stadium, and it hasn't been built over a stadium, and I honestly, in that form, it probably is too complex to be realized at that 100+ meter scale. Mm-hmm. But it was no accident that, as a proposition, I said I'll design a retractable roof over a stadium. I could have used the design approach I had for a lot of different things, but at that time, in the early 90s, and someone who was a little bit coming to architecture from the outside, a roof over a stadium was a clear reason to do that. It had been done. This was like a way to do it, maybe in a more complete way, in a more innovative way. When in the sort of gestation of ideas in thinking about architecture over the years, and then sort of coming into the sort of the 2000 era with a lot of focus on sustainability and green performance, the concept of adaptive buildings also began to gestate in my mind and a lot of people's minds. Mm-hmm. And with that, there was a very conscious decision on my part and some of the people on my staff and our partners. Well, if we're looking at adaptive buildings, specifically using these transformable mechanisms and ideas, what part of the building would you work on? Mm-hmm. And the facade and the building envelope seemed probably, and does seem, is more, there's more benefit for energy performance, and it's a much more practical notion. So, for those of you who know, I mean, I do build very large very large transformable structures, but the biggest ones tend to go into stage sets for theater. Mm-hmm. To do that and to make a building where it, really morphs and turns inside out, it's actually hard to really come up with a proper justification, to be honest. It's probably the, it's the gee whiz, it's the wow, but you know why. So, but maybe some of you can think of why. So,
well, I think an operable stadium roof, they're surprisingly unspectacular right now. And I think maybe it's the number of components that makes it difficult, but I think it's also the number of components that would make it spectacular.
Well, yeah, and there's number has a very, it has an interesting, I mean, scale and number are kind of the two abstract quantities that I think a lot about with the different types of structures that I build. It's a very interesting technical issue, it's a very interesting perceptual issue, and I think it has some deeper connections with the way that nature works versus technology works as well. But just speaking about perception, I mean, I found that, if movement is one thing, so an object here and an object there, you see that and it's just like a solid object that's changed its relationship to another object. As I call my structures transformable, but it's really just moving this glass around. I'm just rearranging the parts. Nothing is turning into something else. But the relationships are changing, and I've noticed there's a threshold of, 1 or 2, it's a roof, going. If you get up to 100 or 1,000, it's more like, it's melting forms, it's things just coalescing into other things, it's clouds in the sky, it's water moving. It may not be doink, 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 but it's got its own soundtrack to it. And then there's like, but where does it shift? And then you're in this sort of interesting kind of cost benefit of like, So a retractable roof, right now, most of them, sort of top out at about 4 pieces, 4 moving pieces. If you got it up to a dozen, you might have something actually quite different.
Yep. And for the U2 set, the recent one, how many components are in that?
If you're counting, if you're doing it as far as solid links.
Well, how many moving pieces?
Moving pieces, because each one of them is made up of numbers. It's probably on the order of 1,200 or something like that.
And how many servos or motors?
There are 40 chain hoists that control it. Did anybody in the audience see the U2 concert? Few people. Anyway, it's a big structure that hangs overhead, over Bono's head actually, that weighs about, the movable mechanics weigh about 30 tons, and when it extends, it ends up being about 7 stories high. So it's a big piece, and it has that kind of sort of melting quality of, where.
Why didn't we get that for the show? Where is that now?
It's in, I think it's in pieces in a warehouse, stripped of its electronics, which have all been resold.
Oh, really?
The rock and roll industry is not sentimental.
Okay, now I know we weren't really friends in the 90s. We were acquainted. I always felt like you were a little bit cautious with me and a lot of my other friends, and I think I know why.
Jeez, Greg.
But
you did the book Folding in Architecture. I'm thinking that's when we.
Yep, that's when I got your interest anyway. What did you think was going on with people that were looking at animation software and topology, and what's your relationship to that moment in the 90s, and how are you similar or different, let's say?
In terms of what was happening in architecture?
Yeah.
I think that my own career was very much on a track. I really, it wasn't building a company, it was a kind of a practice, but I really thought in terms of projects, like how can I get somebody to pay for something that I want to make, because it really what interested me. if I could have played the role of a designer, that other people would then take the design in whatever form and build it, I think it probably would have suited me really well, but nobody would do it. You know, it was hard enough to get a client to say yes, but they would only say yes if they looked you in the eye and I said, I will deliver it, I will maintain it, I'll make this happen. And in architecture, I guess, you know, it was problematic, and it probably still is that, you know, there was this other kind of way. I mean, some architects like to make things, but by and large, it was kind of there was a lot of interest in these ideas, but they not so much in the sort of in the practical consequences of actually dealing with taking it on. And then there were these special kind of things, and folding in architecture was, you know, it was extremely interesting to me. The book was, it was then. I mean, when I went to art school, I was reading, you know, Anti-Oedipus and all this sort of philosophy, not understanding a word, but I'd see things like folding, et cetera, and I'd go,
Like a good architect.
But, you know, it was like my folding wasn't that folding. It was, you know, it was like two pieces of metal with a hinge between them.
Yeah.
And, you know, I mean, it's still an open question, like, does that, you know, I mean, there is some philosophy to it somewhere, but, you know, what it is, you know, it's a bit unclear. But, you know, I taught for that couple of years at Columbia with Guy Nordenson, and that was when Bernard Tschumi was dean, and it was the hotbed of the digital studio, and, you know, it was extremely exciting. I'd say I was on the periphery, but not to say that I wasn't, you know, interested and influenced by it.
Well, I think that raises another issue which we didn't really have to grapple with these projects, because everybody was really, well, no, actually Shoei was working closely with an engineer. But I think around this time, there were some architects that were using the software in their offices, but there were many more architects who were hiring Buro Happold or Arup, and it was really the engineers that had the technology. And a lot of times you would even get pin-barred underlays from your engineer, and then the architects would just be drafting over them with pencils and pens.
And that whole process was, you know, it was kind of antithetical to, but then there was, you know, these other, you know, there were other streams. There was, you know, a very influential conference for me was one called Bridging the Gap, which was, I think, at the Guggenheim in '89, and that's where I first saw Peter Rice speak, and was able to make a contact with him and had some conversations where, you know, I mean, those 3 conversations I had with Peter Rice were probably as incredibly influential in terms of direction, you know, just a couple things that he said, because he wasn't like, you know, he was this, he really was that kind of universal engineer, designer. He worked with architects, but he was directly engaged with the concept, you know, with the design concept. It wasn't that separation between here's the idea and here's the implementation, and you can work in this layered way. And I think that for practical reasons, you have to do that a lot of the time, of course. But it's, you know, the design I'm interested in is something where all of these things do come together. And, you know, I'd say if I had a, you know, I mean, I have my own, certainly have my own concerns and critique of the computer in, you know, in design and as used in design. And I think it's, you know, on balance, I think it's a huge benefit. But there's this side to it which I think has always existed, which I think is much more insidious, which is that, you know, there's this sense, and you were alluding to it before, but there's a sense when you design with a computer, it's this kind of sense of frictionlessness. You can just sort of, you can operate, you can go here. You might script something and then it comes back to you. And I don't believe in that, you know, that frictionless quality is not, you know, it's like it's the constraints that are interesting. And, you know, you have to realize when it feels like you can go anywhere, it's just because somebody's like guiding you on the track. It's frictionless as long as you stay on that route.
Yeah.
And you know, that I think is that that's very much not what I'm about. It's, it's more that the computer is enabling an idea that existed before to happen.
Mm-hmm. Okay, in terms of audience, which we didn't talk about with Peter, we should have. How do you think the audience relates to a kid with a toy that can transform? Or one of these things that you could get at the airport that transforms? And how has that changed expectations for buildings and expectations for things around us?
It reminds me of one thing that Peter Rice told me that, I don't know if the audience knows who Peter Rice is, but legendary engineer, did a lot of work for Renzo Piano and Foster and Richard Rogers. But I remember once he told me, like, because I was just starting to make the toys when, and at the times I met him, and he said, you better stay away from the toys because no one will ever take you seriously.
Really?
And, hopefully they still don't, but, I mean, making toys is, it's an honor to make toys. I mean, that's, if you can put something in the hands of an 8-year-old and they like it, I mean, that's like, this is a person who will not hesitate to tell you, they don't have to tell you, they'll just walk away without a word. So I've learned, I learned an enormous amount by making toys. And, one of the things that, it's because I came about this in a kind of from a sort of a mathematical perspective, there's a lot of layers of abstraction to get to the physical thing. And so I imagined that, that somehow the way that I live making these things is the way that others see them. But when you see a kid with a toy and it's just this physical wailing and just, putting yourself into it, that's informed really the way I think about a lot of what I make is that, we're making things that are, it's not primarily visual. It's visual, but it's tactile, it's visceral, there's a lot of these sort of, I can't remember I can't think of the word, but these sort of senses that you have that are they're not the 5 senses, they're the sense of, these sense of physical shifts that you feel in your body. That's it, proprioception. Mm-hmm. That's it, thank you, proprioception. And so toys was making those toys and, kind of learning about how an object that doesn't have a character or a story or a set of rules can go out there and yet still be a great toy is, that certainly has been a high note.
Well, I really believe that when digital technology enters Hollywood, when it gets on your telephone, when it gets on your television, that you start to expect, it changes the way you think about the physical environment and the built environment. And I think it's something that architects and theorists need to really consider is to what degree are the expectations for a building changing? I mean, to what degree do people expect their stadium to be built out of 12,000 parts and move like, something liquid versus being made out of 3 parts and, look like something from the 19th century? And at what point does it stop being architecture? I think that's probably a debate we're not all ready to have, but I do think the audience for your work at building scale has to be different today than it was 20 years ago, because people just expect, different kind of intelligence from the environment.
That is true, and it's not easy for me to know. I think that designers of a certain stripe are extremely fascinated by that question.
What stripe is that?
Meaning designers who are interested in technology and sort of like pushing the boundaries of physical space relative to this digital wave that's, we're sort of in the midst. been in the midst of for a good long time now. I mean, but who I am, you know, just, I mean, in terms of my own, what I make and what I do, I would say that, you know, if I was to say, well, I have, you know, I've got training as a mechanism designer, and that was an influence, and I did a lot of programming and know how to use computers, and computers are used a lot in the process. Mechanism design is much more important. You know, structures is much more important to facilitate the making. I think there's a little bit of, I mean, I see certainly, you know, I'm teaching architects, and there's a certain enthusiasm, naive enthusiasm that says like, oh, well, because we can do it digitally, it's inevitable that we'll do it physically.
Yeah.
And it's like, wow, you know, you've sort of skipped over the real world there somehow, and so I don't know, and I also, you know, I don't know if I'm traditional, but there's certain threads in design that I just respond to, and, you know, elegance and economy, you know, a kind of an intelligent structural, legible structural sort of narrative that goes with what you make. I mean, those are very much part of how I think about it, and the you know, this other side of like, oh, well, we can make objects morph digitally. It's a kind of a motivating metaphor for me. I'm not sure when it becomes reality, though.
Yep. Well, and I think we should open it up, but I think the last thing I'd ask you a little bit more formally is, when you're patenting things, I don't know that much about patenting, but I know you can patent a mechanism, you can patent an organization, you can patent a method of assembly. What are the things that you were thinking of as original IP that you own? Because I think it tells a little bit about your work, how you think about that.
Well, first, the motivation to patent was because I liked the word inventor. You know, I thought that's kind of like, not that many people really know exactly what an inventor does, and that appealed to me. I like the look of patents. If you ever see a real patent, an actual issued patent, it comes with a gold stamp and is on this very toothy paper, and they illustrate them just the way they did 150 years ago. So there's all these things. My patents are within the claims. Basically, you can't claim geometry, but you can claim geometry as clothed in a mechanism, which was what I was doing and what I continue to do when I do patents, which is, so there's a certain, usually there are certain geometric diagrams. In fact, if you look on the screen, you'll see these kind of dashed lines here and there. Those are basically the trajectory lines, so there's no feature on the physical object that's being illustrated that corresponds to those lines, but those lines, in fact, are the claims. It's a mechanism that follows a trajectory which I could describe as a kind of a behavioral piece. So I would say, if, like the sphere, if it folds and unfolds, all straight line trajectories will go in and out from the center. Mm-hmm. So it's a behavioral feature within the mechanism.
Okay. All right, well, so let's open it up to the room and see what questions people have. Oh.
Okay. Maybe you.
What was your first geometrical shape that you brought into a foldable space?
I mean, my original explorations with folding were origami, but it's, which was in the sort of mid-late 80s, but there really was such a continuity of ideas. I'm not sure where, sort of specifically, where
Did you
you're
start
asking.
more with the buckyball or with the other one, the ICO dodecahedron?
That wasn't, to be honest, that wasn't really a concern. I mean, if you look at the pictures up there, you'll see the ones, if you go back to the slide we were on before, on the right is, can we go back to the patent slide? But anyway, you'll see a shape that was a sphere, and you'll see a shape that was more of a faceted. I showed those two shapes precisely to say you can make any shape. And I illustrated those two. So shape is a kind of a, it wasn't, I don't have the, it's not like Bucky where I sort of say, oh, a sphere or a dome is a better shape in some way, although it is in some ways. I mean, it's more economical and efficient, but it's more that you could, it's more of a way of enabling shapes to transform.
Okay, thank you.
Hi. I noticed the date up there on the pattern is 1991. At this time, Chuck, who were you thinking your client would be?
Somewhere between nobody and the whole world. I wasn't very, I probably was, you know, running on a certain kind of faith, you know. It's, I mean, it kind of alludes to another interesting question about, you know, do we invent, you know, the saw on the table metaphor from the last session, but do we invent according to what we need, or do we invent something and then find out what the use is? And I certainly was in the latter category. I just figured it was like these ideas were super cool and somebody would want them for something. But I had, when I started my own practice in 1990, I did have a few clients. I was working actually for another toy company at the time to develop ideas that didn't come to market. Fortunately for me, as it turned out, because it was better that I did it myself. And then also I began a series of sculptures for science museums who were interested in this art that expressed technology and scientific principles.
Well, you were very visionary in that way. Apple is making, what, thousands of patents a month, just in order to protect future things they might want to have.
Yeah, no, that's true. But I think, look, we inventors are a kind of a, you know, we're a funny lot. We just, you know, we think of these things, and you know, just when you think of something like that, you kind of, you assume that it's, you know, it's the answer to just about everything. You just try. Otherwise, you would not put up with what you have to put up with to get anywhere with it.
With these things you've been designing since like the 80s, 90s, and with the computer software that's been evolving and changing as time has gone on, have the tools you've been using ever like gotten in the way of what you were trying to do?
Well, it's never my sense of it. I feel I've found that I found a way of working where I could pursue the ideas that interested me far enough, you know, to take them. I mean, I certainly could, you know, I could have imagined software that does exist today, or at least in better form today, that would have helped. I mean, you know, I still don't necessarily animate my mechanisms on the screen because I understand how they work from that point of view, so I may draw them in a few different positions. I think there has been an absolute phase change in terms, not really in terms of the way I work, but the way my staff works and in the way just the larger culture is working, where now the notion of designing by algorithm, scripting, so that you're working with, I mean, parametrics is broadly used, but in a certain way, is very much part of how I've always thought about design. And I think that the changes that are taking place are partially because the technology is different, the programs are different, but also it's just the period of, you know, where socially there are just many, many more people who are adept at thinking this way and designing this way, and that creates a kind of a sea change of possibility. So I think we're kind of, you know, we're still actually on the beginning of that wave. Not because the technology will continue to get better, but I think it's more that the users are changing how they think about it.
I mean, maybe from the last session, Peter threw it out there as a provocation. We might as well pick it up when he said, well, there are form finders and there are form makers.
Yeah, that's interesting.
Now, I would assume it would be virtually impossible for you to be a form finder, that you're a form maker. I mean, that the...
Yeah, I'd say that that's true.
Yeah.
Form finding, I think it also, it ties into also the thread of, you know, how, I mean, form finding is this, I think it sort of tends towards a, you know, almost like that biological metaphor, because nature's form finding, it's constantly, you know, it's constantly adapting to, you know, species or nature is adapting to conditions, so the forms emerge from that, and that's, there is, you know, it's certainly, on one level, that is, it's not what designers do. I mean, we have to start with ideas, and yet I wouldn't sort of just throw that out either. I think there is something about I do believe there's something that we can learn about, you know, the notion of design relative to nature and the way that scientists are now designing with biological materials and structure, making structures out of DNA. It's like these boundaries are sort of like just blurring as we speak, and it's, you know, it's not really, it's not up to, you know, it's not up to designers and architects. You can sort of set the boundaries in your own practice, but these are like big changes that are just happening.
Mm-hmm. But I think for you, the part to whole relationship and the mechanism, it's not a one-to-one, that's for sure. I mean, like you said with your patent, you can have a component, and that component could array itself in all kinds of different ways. But do you ever foresee a situation where it could array itself in any way it wanted? I mean, with more computing power or more parameters, or do you think?
Well, any way it wanted, meaning like the designer has an intention and can kind of just set it in any direction they desire,
Yeah,
or?
Like somebody says they want the horse's head in the Lewis house to change size.
That we could do.
That you could do.
We could do that now.
Okay.
I mean, it would be a fair amount of work, but but pretty much within grasp. If you said you wanted the horse's head in the Lewis house to turn into the fish or the or something like that, that would be a little bit more effort, but we're working on it.
All right, no, these are okay. This is actually getting interesting now.
Well, that's. I mean, you know, for me, if there's a lot of creative, you know, pleasure that I get out of making what I make, but I'd say on the inventive level, that's exactly it. It's like, you know, there's a I mean, it's largely speaking, it's a kind of a misconception that the most difficult thing for an inventor to do is to solve a problem. I mean, solving a problem, if you know what you're trying to solve,
yeah,
it's like, it's more or less, I mean, it may be possible or not, but you basically have a direction. But picking the right problem is, you know, I think that's where there's much more art. And I was, you know, I mean, I think in some ways I was lucky. I picked a pretty cool problem, like how to design objects that transform. It was a problem that was, it was a good way to pose the problem. It was within my own means to get somewhere with it. And now within that, the expandable shapes, at least of the particular kind that you see, it's like, okay, we've got that, we worked it out, it's in the patent, and there's some more math you can do and get better at it, but that works. The problem of morphing shapes is I think that's a well-posed problem. How can we turn the horse heads into a fish? How general can we make that happen? That is more the digital metaphor, you know, at least another step in that direction. Yeah, personally, I think that's a tractable problem. It's not easy, but I think you can do that structurally.
Great.
I don't know if I'll be the one to do it.
Two more, because that's such a great way to end it.
Well,
All right. These better be good questions.
no, first, thank you for
No
being
pressure.
an inventor. I think we all need inventors all the time. My question is about the relationships between architects and engineers, and especially about the language they share and the concept they share. according to materiality and construction, the way architects and engineers see construction and materiality. In 2004, there were a book by Neil Lynch entitled Digital Tectonics, in which he argued for a structural turn, something that he said that because of the digital tools, architects become more interested back again in structure. And so my question would be, do you think that using digital tools, the way architects sees construction and materiality gets closer to the way engineers see construction and materiality?
So basically the question is, by using computers, do architects become closer to the way engineers see construction and technology? Yeah.
Be honest. Don't candy coat it for the crowd.
No, I think there are really, I mean, honestly, there are two, I mean, I hate to equivocate, but there is a yes and a no to that answer. Yes, in the sense that design is, basically it's the role of abstraction. I mean, engineering is basically, there's just the level of mathematical abstraction that you need to apply to a problem. You know, you can't just say, I can look at it and see it and solve the problem. You have to have that insight into physics and chemistry and math and whatever it is. And by programming, by making design a programming, by bringing programming language into design, you have these logical operators that are causing an abstract view, and in that sense, it's closer to it, to the way the engineer sees it. But the physics is subtracted out, and that's the issue. That's an issue. I mean, the engineer, a good engineer, it's like, first off, you just have to respect laws of physics and reality, and the computer, unless those laws are somehow programmed in as rules, you can more or less violate them at will, and people often do. But I think it is changing. It is changing the way that it's changing. It is changing that relationship. I think in the ideal sense, for certain types of projects, there's a better possibility for a much more lateral communication between the architect and engineer, because the architect is supplying these quantifiable models constantly, and the engineers can kind of interact with that in a much more fluid way.
Okay, so I don't know if it's the last question. I was very interested in seeing these kinematic tools and the coupling with the digital fabrication that comes very quickly to be able to visualize or do a prototype, because kinetics needs actually to have a physical component to see how it works, the mechanism itself. And I've seen recently the appearance in architecture of Arduino, for example, a physical computing that actually can be works as a mechanism, but as a software mechanism. Do you see it as an extension of like the pursuit of making animate the object? Or is it just like the extension of digital fabrication into a 4D that we're talking a bit more today, that you can control movement in space of mechanism itself?
So the question is about embedded control in built work, and whether that's and what role that would be playing in.
Yeah, but do you think it's like the idea that is reinforced with physical computing is the pursuit, the idea of having animate object? It's like you're really trying to make the object animate, as we were talking a bit before, yeah. Or it's just the production that is now able to achieve that as basically.
Well, I think the project of making animate objects generally and animate buildings specifically is, it's very much a work in progress. The use of, embedded or distributed control, like Arduino controllers, et cetera, it's a critical piece. If you don't have that, you won't get anywhere with this, with this larger project, but it is only a piece. You know, there still is this, again, this, you know, physical component, which is very much part of the system, you know, that needs to, that I think is still, in some ways, you know, there's a lot of work to do. But it's, no, I think it's very exciting that that's almost, you know, that's becoming kind of part of the lexicon of, you know, many young architects now as they do think about how they're going to hook up motors and controllers, et cetera. And I mean, the best thing about it is that, you know, there's all these experiments happening, and, you know, these experiments, of course, a lot of them will not work, or will only work once, or will, you know, but it's, you know, when you get a lot of that happening, it's like the collective intelligence keeps rising. So they're on my heels. I got to keep going.